We want to solve 3z to the power 4 minus 3z cubed minus 14z squared equals 11z plus 3. We're going to start by, first of all, putting everything on one side, and then we'll use the factor theorem to try and find linear factors for the left-hand side. So, first of all, let's pop these things over onto this side. So we get 3z to the 4 minus 3z cubed, take away 14z squared minus 11z minus 3 is equal to 0. So we're going to use the factor theorem. The 3 at this end means we only need to worry about plus or minus 1 and 3, but the 3 on this end means we might need to worry about a third, and 3/3 is 1 anyway. So let's let f of z be equal to 3z to the 4 minus 3z cubed minus 14z squared, take away 11z, take away 3. F of 1 is 3 minus 3 minus 14 minus 11 minus 3, and that's definitely not 0. What about f of negative 1? Well, that would be 3 plus 3, take away 14, plus 11, take away 3. And that is 0. So we know that z plus 1 is a factor. But because we have a quartic, that's probably not enough yet. So let's have a look at f of 3. So that's going to be, we probably need a calculator now, 3 times 3 to the 4. So 3 to the 5 is 243. Take away 3 times 3 cubed, well, that's 81. Take away 14 times 9. So take away 1, 2, 6. And then we've got take away 33 and take away 3. Let's see what that comes to. So we've got 2, 4, 3, take 81, take away 1, 2, 6, take away 33, take away 3. Oh, that is 0. Excellent. And therefore, z minus 3 is a factor. And that means that z plus 1, z minus 3 is equal to z squared minus 2z take 3 is a factor. So 3z to the 4 minus 3z cubed minus 14z squared, take away 11z, take away 3, is equal to z squared minus 2z take 3 multiplied by another quadratic factor. With 3z to the 4 on this end, we must have 3z squared here. This is a negative 3, this is a negative 3. We must have a plus 1 over here, and we're not sure what goes in the middle yet. But we could use coefficients. For example, let's use z cubed. On the left-hand side, we have negative 3. What will give us a z cubed on the other side? This will. So that's going to be negative 6. And this will. And that's going to be plus a. And that means that a is equal to 3. So we have z squared minus 2z minus 3, 3z squared plus 3z plus 1 is equal to 0. Now we know from our earlier work that this is going to lead us to z plus 1, z minus 3, and therefore it's going to give us the solutions -1 and 3. The other solutions will come from this quadratic. So we have 3z squared plus 3z plus 1 is equal to 0. Let's use the quadratic formula. Z is going to be -3 plus or minus the square root of 3 squared minus 4 times 3 times 1, all divided by 2 times 3. So that's -3 plus or minus the square root of 9 minus 12 over 6. So that's going to give us -3 plus or minus root -3 over 6, which is -3 plus or minus I root 3 on 6. Once again, when we end up with complex roots, and we started with real coefficients, we get a conjugate pair.